Welcome back. In this video, we're going to go over section 2.7, which is about absolute value, equations, and inequalities. Where we'll start, though, is to take a look just at what absolute value is, along with a couple of examples, and then we'll go step by step through equations and inequalities. So what absolute value tells you is the distance of a number from zero without regard to which side of zero it's on. So for example, if we want to know how far is 10 from zero, 10 is 10 units away from zero. And the way we symbolize absolute value is a pair of vertical bars, like brackets without the legs on it. So just a pair of vertical bars. What we're doing is finding the distance of whatever's inside from zero. The absolute value of -4. -4 is 4 units from zero. It happens to be on the left side, but it's still just 4 units from zero. The absolute value of 0 is 0. It is 0 units from 0. The absolute value of -116 is going to be 116. It's 16 units away from 0. Sorry, 116 units away from 0. So absolute value is a distance. Distance is always a non-negative number. So that's basically it. As far as order of operations go, the absolute value bars kind of function like parentheses. So you work on the part that is inside first. So here we have 2 times the absolute value of 5 minus 3. 5 minus 3 is 2. So this is the same as 2 times the absolute value of 2. The absolute value of 2 is 2. And so we would just end up with 4 for that. Okay, over here we have -5 times the absolute value of 6 minus 10. So this is the -5. And then 6 minus 10 is -4. Okay, so this is -5 times the absolute value of -4. So we'll have -5. The absolute value of -4 is 4. So we'll have -5 times 4 is -20. And then if you're concerned, well, I thought you said that absolute value is always non-negative. It's true. The absolute value part is always non-negative, but here we've multiplied by -5, which turns, of course, our 4 into a negative product. All right, so that's a quick run through for absolute value. We want to start working on equations next. There are a couple of different formats of equations that we're going to look at. The first kind of structure would be the absolute value of something equal to some number. For example, the absolute value of x equals 5. And we're trying to solve that. So we're trying to find any and all values of x that are 5 units away from 0. And thinking about how the number line looks, there are 2 numbers that are 5 units away from 0, 5 and -5. So we could have x being -5. We could have x being 5. So there's 2 possible values here. It's a set of numbers. We're going to write that inside of curly braces. We have -5 and 5. And that's it. Just 2 individual numbers that are 5 units away from 0. Okay, moving on. One that's a little more interesting. We've got the absolute value of 3x minus 5 minus 1 is equal to 6. So before we start trying to think about distance from 0, we need to isolate the absolute value part. So if you look at this and think, okay, -6 and 6, you're a little too early. So we want to add 1 to both sides of our equation first. This is the absolute value of 3x minus 5 equals 7. Okay, so always get the absolute value isolated first. So there are 2 numbers that are 7 units away from 0, -7 and 7, and 3x minus 5 could be either of those. And so this leads us to 2 little equations that we can solve. Either 3x minus 5 is -7, or 3x minus 5 is +7. So we're going to solve each of those separately. So we'll add 5 to both sides. This will give us 3x is -2. So that x is -2/3, or 3x could be 12, so that x is 4. So once again, there are 2 values for this that satisfy the equation, -2/3 and 4. We have -2/3 and 4 as our 2 possible values of x. Okay, let's try one more. This one, why don't you take a minute, pause the video, and try this one yourself, and then restart the video and see how you did. Okay, so our first task is going to be to isolate the absolute value part. So I'm going to start by subtracting 3 from both sides. We'll have 2 times the absolute value of x minus 5 is equal to 6. Dividing through by 2, we'll have the absolute value of x minus 5 equals 3. So this means that x minus 5 could be in one of two places. It could be at -3, or it could be a +3. This gives us two linear equations to solve. Either x minus 5 is -3, so that x is 2, or it could be that x minus 5 is +3, so that x is 8. So our two possible values here are going to be 2 and 8. Okay, one more, and then we're on to our next type of equation. Here we have the absolute value of 3/4 x minus 5 plus 9 equals 4. Our first task would be to isolate the absolute value part. And so I'll start by subtracting 9 from both sides. We'll get the absolute value of 3/4 x minus 5 equals -5. And this one, there's no solution. You can just stop right there, say no solution. You could give the empty set in one of the two forms, either the fat zero with a slash through it or the empty curly braces. The reason why there's no solution is because the absolute value is always greater than or equal to 0. It's a distance, right? And so if it's a number that is greater than or equal to 0, it's never going to equal -5, regardless of what you put for x. So there's just no solution there. Okay, on to our next type of equation. So the ones that we were working on after you've isolated the absolute value was absolute value of something equaling a number. In the next type of equation, we'll have absolute value of one thing equals absolute value of something else. Okay, and so again, interpretation of distance of this as distance is going to help you get the right process to follow. So you want to think of it as you've got two numbers on the number line and they're equally distant from 0. So if they're equally distant from 0, they could be in the same place that is equal to each other, or it may be that they're equally distant from 0 but on opposite sides, that is, they're opposite. So maybe 12 and -12, or 5 and -5. So if they're the same distance from 0, because their absolute value is the same, they could be the same, or they could be opposites of one another. So this is going to, again, lead us to two kinds of, or two possible equations. So let's try this one. So we have 7x minus 3 in absolute value is equal to the absolute value of 3x plus 7. So it could be that 7x minus 3 is equal to 3x plus 7. If they were equal to each other, then their distance from 0 would sure be the same. Or it could be this. Okay, I guess Zoom has to crash at least once every time. Sorry about that. All right, so we have 7x minus 3 could be the opposite of 3x plus 7. So this is going to give us two separate inequalities to solve. Equations to solve. So here, let me subtract 3x from both sides. 4x minus 3 will equal 7, so that 4x is equal to 10. X will be 10/4, which is the same as 5/2. Okay, that will be our first value. Then for the equation on the right, my first task would be to distribute the negative. And then let's collect the x's on the left side. So we'll have 10x minus 3 is -7. And collecting constants on the right side, 10x will be -4, so that x is -4/10, or -2/5. All right, so that's pretty neat. So we have -2/5 and 5/2 as our possible values. So the plan, basically, when you have absolute value of one thing equaling absolute value of another, is to set them equal to each other, or one would be the opposite of the other. All right, here is one for you to try. Take a minute, try this one, pause the video, do it yourself, and then restart the video and see how you did. All right, so let's do it. We have 6x minus 5 and 3x plus 4. Their distance from 0 is the same. So that means that it could be that 6x minus 5 could actually be the same as 3x plus 4. Or 6x minus 5 could be the opposite of 3x plus 4. Okay, this gives us two small linear equations to solve. I'm going to work on the one on the left first. So let me subtract 3x from both sides. So we'll have 3x minus 5 is equal to 4. Add 5 to both sides, and we'll have 3x is 9. That will make it so that x is 3. Okay, for the one on the right, we'll start by distributing the negative that's on the right side. Collect variables on the left, so let me add 3x to both sides. We'll have 9x minus 5 is negative 4. Add 5 to both sides, 9x will be 1, and so that makes x equal to 1/9. So our two possible values are going to be 1/9 and 3. Okay, and that'll do that. All right, that takes care of our look at equations. Next up, we want to look at inequalities. As with equations, inequalities come in two types also. The first type that we'll consider will be the kind where you have absolute value of something is less than or equal to some number. Less than or equal to or less than some number. So let's try. The absolute value of x is less than or equal to 7. So that says that the number we're looking for, its distance from 0 is no more than 7. That is, it's within 7 units of 0. So that means that x is greater than or equal to -7 and less than or equal to 7. In interval notation, that's the interval from -7 to 7. Please note here that the answers to inequalities are going to be intervals rather than just sets of numbers. If we were doing an equation, absolute value of x equals 7, we'd have literally two numbers, -7 and 7, and that's it. Make sure that you know the difference between a set containing two numbers and an interval containing a whole interval of numbers. Okay, also worth noting, in this problem, the only difference between this and if it had been the absolute value of x less than 7 instead of less than or equal to, the only difference would have been it would have been round parentheses instead of square brackets. So that's the only difference. Okay, let's try more. Here we have the absolute value of 2x minus 1 is less than or equal to 5. So that says that 2x minus 1 is somewhere between -5 and 5. 2x minus 1 is in there someplace. So that means that -5 is less than or equal to 2x minus 1, which is less than or equal to 5. So again, this gives us a three-part inequality. We're going to need to solve that. We'll do that by first adding 1 to all three parts. We'll have -4 is less than or equal to 2x, less than or equal to 6. Next, we're going to go through and divide by 2. So that'll give us -2 is less than or equal to x, less than or equal to 3. In interval notation, square bracket, -2, 3. And that will do it. Okay, here's one to try. Take a minute, pause the video, try this one yourself, and restart the video and see how you did. Okay, so for this one, 4x plus 5 is somewhere between -3 and 3, right? Its distance from 0 is less than 3 units. So we'll have -3 is less than 4x plus 5, and that is less than 3. Subtract 5 from all three parts. That'll give us -8 is less than 4x is less than -2. Now we're going to divide through by 4. So -8 divided by 4 is -2. Middle will have an x. -2 divided by 4 is -1/2. So we'll have -2, comma, -1/2. And again, that will be in parentheses because it's a strictly less than, not a less than or equal. Okay, we're almost there. We have just one more type of thing to consider. In this time, it will be absolute value greater or greater than or equal to some number. So before, when I said there were two kinds, it's not based on whether or not there's the or equal to or not. The two kinds are, is it absolute value greater or absolute value less? Absolute value less, we just did those. They turn into three-part inequalities. Absolute value greater, it looks like this. We'll start with the absolute value of x is at least 2, greater than or equal to 2. If you have or want the numbers that are at least 2 units away from 0, those will be the numbers that are 2 and higher, or -2 and less. So in interval notation, that'll look like negative infinity to -2, union 2 up to positive infinity. Okay, let's try that again. Okay, 4x minus 3 in absolute value is greater than or equal to 5. So that says that 4x minus 3's distance from 0 has got to be at least 5. So maybe 4x minus 3 is bigger than 5. Or maybe 4x minus 3 is less than or equal to -5. So this gives us two inequalities to solve. Okay, and so let's solve each of those. So add 3 for the one on the left, and then divide through by 4. X is less than or equal to -1/2. Okay, 4x minus 3 greater than or equal to 5. Let's add 3. And then divide through by 4. X is greater than or equal to 2. Okay, so let's put together those two intervals using a union sign. So we'll have negative infinity, comma, -1/2, square bracket, union 2 to infinity. Okay, and that will do it. Okay, you'll notice that when we were doing the absolute value less thans, the answer was always one interval, and we had a three-part inequality. All the ones where it's absolute value bigger, you have two separate inequalities to solve, and you end up with a union sign. Okay, the other thing to mention is in here, a lot of times people get confused right around here with the yellow highlighting. They want to know, okay, how do you know which one to make negative? You turned around the inequality sign. Why did you do that? All of that is given by the picture. I know a lot of times people don't feel like making a picture, but a picture can help. Remember that the absolute value tells the distance of a number from 0, and we want this one to be at least 5 units away from 0. So how could that happen? It could be at least 5 units from 0 by being negative enough or positive enough, less than or equal to -5, greater than or equal to +5. It's the picture that guides how these first two inequalities are made. Okay, here's one for you to try. We've got absolute value of 3x minus 4 is bigger than 2. So that means, I'm going to start with my picture. Sorry if you don't like it. Okay, so we want to be at least 2 units away from 0. Okay, so how can that happen? We could be bigger than +2. So 3x minus 4 could be bigger than +2. Or it could be less than -2. Remember, less than is on the left, greater than is on the right. Okay. All right, so 3x minus 4 is less than -2. We'll add 4. So 3x is less than 2, so that x is less than 2/3. Okay, that will give us half of our inequality. Skipping over to the other side, we'll have 3x is greater than 6, or x is greater than 2. Okay, putting together our two intervals using the union sign, we'll have negative infinity, comma 2/3, union 2 to infinity. Again, here, notice that because of the fact that this was a strictly greater than, we had parentheses on it. If it had been a or equal to, I'll give you an extra example. If it had just said greater than or equal to 2 and everything else was the same, the only difference would be, that's too quick, sorry. The only difference would be on the 2/3 side, we would have a square bracket. And on the 2 side, we would have a square bracket, but everything else would be the same. Okay, so to kind of summarize, on the equations, we had absolute value of something equal to a number, or absolute value of something equal to the absolute value of something else. Either way, we set 2 little equations, and we often ended up with 2 answers. For inequalities, we saw that it will be either absolute value less or less than or equal to a number, or absolute value greater or greater than or equal to a number. In the first type of inequality, we're going to end up with a 3-part inequality and 1 interval for our answer, because we're trying to say, okay, we have to stay within a certain distance of 0, and so that's going to give us 1 single interval. In the last type, we saw that the distance from 0 has to be at least a certain amount, and we have to stay away from 0 by a distance. And this gives us 2 separate intervals hooked together with a union sign. So you're always going to end up with a union sign on those. All right, that takes us to the end of this section at long last. Let me know if you have any questions, and have a great day.